we know that the normal stress X is equal to Px over A plus by mz over Izz multiplied by y. Okay, so we know that Px is going to be compression. So Px is equal to, our Px is 1073.313. Okay, minus 1073 minus 1073 point. My short-term memory is like a dog. Hopeless. 313 times 10 to the power 3. Cross-sectional area is equal to 1. And then at element D, the moment induced by Z, we have done this, right? The moment induced by Z at element D is negative. So minus mz, which is equal to what? Mz is equal to 1.878 times 10 to the power 6 divided by 1 over 12. And the y is 0.5, right? Because over here at point D, right, this distance to here is half. Okay, so this will be equal to so it's minus 1073.313 times 10 to the power 3 minus by 1.878 power 6 times 0.5 divided by 1 over 12, which is equal to 11.268 times 10 to the power 6. Let me do it again. 1.878 power 6 times 0.5 divided by 1 over 12. 11.686, 1.878. Did I do correctly? 536.636 power 3 times 3.5. 1.878 power 6. So the normal stress is 1073.313 power 3 plus by 11.268 power 6. So it's equal to minus 12.341 times 10 to the power 6. Okay. And then, okay, so this is normal stress at D. The shear stress at point D. So if you look at the shear stress at point D, right, induced by this is equal to 0. Okay, that is our element D. Okay, so if you were to draw element, okay, I'll do further because you guys know this already. So this will be equal to minus 12.341 times 10 to the power 6. This is the element. Okay. So next we have to consider element E. Okay, consider element E now. All right, so stress X at element E is equal to Px over A plus by Mz over Izz multiplied by Y. And we know that this is equal to 0 because element E is at the what? Neutral axis. Okay, so Px over A is equal to minus 10 or minus 1.073 times 10 to the power 6 psi, because there is no stresses induced by the bending moment. Okay. However, next we have our the shear stress at point E. So we know that the shear stress at point E will be its maximum. Okay. So the formula to apply is V over I Q divided by T. So we know the V is equal to what? 536.656. 536.656 times 10 to the power 3. We know I is equal to 1 over 12, and we know the thickness is equal to 1. Again, we have to find the first moment of area. So what I'm going to do, I'm going to push it over here. Okay. So the Q is equal to A y bar, right? The area, so it's just the top half. So if we look at the cross section, right, we only need to consider this area over here, right? So the width is 1, the depth is 0.5, the y bar is half multiplied by half. Okay, so this is our width, depth, y bar. Okay, so this is equal to 1 over 2 power 3 or 12. So it's 1 over 8 inches cubed. Okay, so our shear stress at point E is equal to 536.656 times 10 to the power 3 Q over I. Thickness is 1. So this is equal to 536.656 power 3 times by 1 over 8 divided by 1 over 12 divided by 1 is equal to 804 or 0.804 or 805 times 10 to the power 6 psi. So when that's the case, right? So now we can construct our element. Okay, you don't need to do the element, but I just want to do it for you to see. So at element E is pushing, because the shear is going up this way, right? So Vy, so the shear force is going this way. So basically it's positive shear, 0.805 times 10 to the power 6 psi. Okay, psi should be in small, I think. And then our normal stress in the x direction is compression, 1.073 times by 10 to the power 6 psi. Okay. I don't know it's my answer right or not. Let me check. Element A 0.805, and then the normal stress is, yeah, it's the same. Okay. Then we are going to look at element F, the last one. So consider F. Okay. I'm going to again copy this. Okay. So consider element F. Okay, so the stress X is equal to Px over A plus by Mz over Izz multiplied by Y. So the Px again we have calculated already. So the Px is minus 1073 minus 1073.313 times 10 to the power 3. Now, the moment about Z, okay, that's where this is so useful. Okay, if you look at here, the moment about Z is going to induce a what? A positive at point F. So this is plus now. Okay, and the value to add is 11.268. Why 11.268 also? Because the y distance are the same for point D and point F. So 11.268 times 10 to power, I believe it's times 10 to power 6. Okay, times 10 to power 6. So this is equal to minus 1073.313 power 3 plus 11.268 power 6 is equal to 10.194 times 10 to the power 6 psi. And we know that the shear X is equal to, or the shear is equal to 0, right? So when we draw this, we draw element, and this is going in the tensile direction, 10.194 times 10 to the power 6. Okay. Okay. Now, what I'm going to do, I'm going to stop here now. You all have any other questions to ask me? So as I said, I have to go. And anyone, any other questions before I go? Anyone, please? Okay. Anyone, any other questions? Now, if you have questions during this time, okay, send me a message on Teams, okay? I will record a video to answer your question, okay? Or I'll call you personally, either one, okay? If that's the case, thank you for your time. I hope I clear most of your doubt. Don't forget your term test is Tuesday, 10 o'clock to 9:30, okay? If that's the case, goodbye then. Bye. Bye. Study hard, okay? It's not that difficult.